Hello, this is the fourth video of the fourth calculus series on integration techniques for OCR Pure Core Further Mathematics, and we will integrate using substitution x equals tan u. You already know the result that the integral of 1 over 1 plus x squared dx is arctan x plus c, and be familiar with the identity sec squared u equals 1 plus tan squared u, and that the differential of tan u is sec squared u. Thus a substitution x equals tan u may be useful in integrating functions involving 1 plus x squared. In this example we have a 1 plus x squared as a factor in a denominator. Therefore we will try the substitution x equals tan u. We know that differentiating this gives us sec squared u. So, putting that in, we'll talk about the limits in a minute, would give us 1 over 1 plus tan squared u to the 3 over 2 sec squared u du. Now when x equals 0, tan u equals 0, so u equals 0. And when x equals 1, tan u equals 1 gives u equals pi by 4. So as we need to change those limits as well, so that the whole integral now is in the terms of u, that's how we would do it. So we have a sec squared u in the numerator, and the denominator will be sec squared u to the 3 over 2, giving us the integral of sec squared u over sec cubed u, which will cancel down to give us 1 over sec. But knowing that sec and cos are reciprocal functions, we can write that as just the integral of cos u du, which integrates to sin u between those limits, which is just 1 over root 2, given that sine of 0 is 0. A common mistake is to be confused about the limits. You may wish to write in when it is x and when they are u limits, and note that we have used radians for those limits. It will also save you some time when you're working out final answers if you know common trig values. For example, sine of pi by 4 equals 1 over root 2. Or when working out the limits, that tan pi by 4 equaled 1. In this second example, using the substitution x equals tan u is not the only method. But let's try it here. So, this would give us 3 tan u plus 2 all over tan squared u plus 1. And then we'd also have that sec squared u du. No limits to worry about here. We can see that the sec squared u and the 1 plus tan squared u can cancel out using this identity here. So integrating 3 tan u plus 2 gives us 3 the natural log of sec u, that's a standard result we can use, plus 2u plus c. Substituting back for x, this would give us 3 of the natural log of the square root of 1 plus x squared. Again, using that same identity. Using the fact that if x equals tan u, u equals arc tan of x, we replace for u with 2 arc tan x, and then not forgetting the plus c. So, when we use x equals tan u, then sec u equals the square root of 1 plus x squared, using that identity. And we can write that u equals arc tan x. And these are results which we've used in this final expression. Note also that using the log laws, if we have the natural log of the square root of 1 plus x squared, we can write that as being half of the natural log of 1 plus x squared. In summary, integrals involving 1 plus x squared may be transformed using the substitution x equals tan u. We make sure that we relate this to the identity that sec squared x equals 1 plus tan squared x, and also note that when we differentiate tan x, we get sec squared x. When we integrate sec squared x, we get tan x. We also need to note that cos and sec functions are reciprocals. However, the resulting integral may need a further technique to be applied. And definite integrals need to have their limits transformed to the equivalent values for the new variable. So you may want to write in x equal and u equal to in those limits to stop you making that common error. In the next video, we look at integrals using either x equals a sin u or x equals a tan u.